Welcome back to the deep dive. Today we are taking a deep dive into some source material about Bazel.
Right, specifically looking at how it gets used, or maybe could be used, with Ruby projects.
Yeah, and our source here is a transcript from a talk. It was given by Alex Rodionov at RubyKaigi.
Always good stuff from RubyKaigi.
Absolutely.
So our mission today basically is to unpack Bazel. What is this thing?
Right.
How does it actually fit into, a normal Ruby workflow? And importantly, what's the real story on Ruby support right now, according to someone who's right in the middle of it?
And that's key, isn't it? This speaker, Alex Rodionov, he's really involved. He is a Ruby maintainer for Selenium, part of the Bazel Rule Authors Group, and crucially, he's the maintainer for the actual Ruby language support in Bazel.
So we're getting it straight from the source base.
Exactly, which is, well, invaluable.
Yeah, it gives you some confidence that this isn't just theory, right? It's based on, actual work and challenges people are facing.
Okay, so let's get into it. First things first. What is Bazel? I mean, if you're a Ruby dev, rake, maybe make. How did Bazel compare?
Well, that's a good starting point. At its heart, Bazel really is a build and test tool. Just like your rake tasks build your gem or run tests, Bazel does fundamentally the same job.
But it sounds like it operates on a different scale.
Oh, definitely. It started inside Google, actually. It was called Blaze back then.
Right.
Then they open sourced it as Bazel. And the reason it was created is really important for understanding it. Google has this, legendary monorepo.
The giant code base where everything lives together.
Exactly. All their projects, one repo, and you've got thousands of engineers working on different bits, but they all interact.
So they needed a tool for that mess.
Pretty much. A tool that could handle that complexity, that scale, and, crucially, that was polyglot.
Polyglot, meaning it works with lots of different languages, not just one.
Precisely. Java and Python worked out of the box, but it has this extension system. So you can add support for Go, JavaScript, TypeScript, Rust, C++, Red, even things like Docker, Helm, Terraform, you name it.
Wow.
It's designed for a situation where maybe 10 teams are all using different tech stacks in the same repository.
Okay, built for huge scale, lots of languages. What else makes it tick?
Two really core ideas, hermeticity and reproducibility.
Hermeticity.
Yeah, it means the build installs and uses only the software it explicitly needs. It manages its own tools and dependencies. Doesn't rely on what's already on your machine,
Okay. And reproducible.
Means given the same starting point, the same inputs, it should always give you the exact same output every time on any machine.
Right, like stamping out the, well, it works on my machine problem.
That's definitely the goal.
Yeah.
Control the environment, make the build totally predictable. And for Google scale, distribution is also key. Yeah, you can build locally, sure. But it's designed so the actual work compiling testing can be farmed out to huge remote server clusters.
Whoa. Okay. So the takeaway isn't just it's another build tool.
No.
It's a build and test system designed for extreme conditions scale, multiple languages, and it's obsessed with consistency and isolation. And it can be distributed.
Exactly. That context is vital. It solves problems you hit at massive scale, but the underlying techniques can help smaller projects too.
So how does it actually do all that? When I type Bazel build or Bazel test, what's happening under the hood?
Okay, think about any build or test you run now. You always have some inputs, right?
Source code, config file.
Right, source code, environment variables, whatever. Then you have an action, you run a compiler, a linter, maybe RSpec, and that action produces some output, a binary file, a .gem file, test logs, something.
Inputs dash action and outputs. Simple enough.
But builds are rarely just one step, are they? The output from one action often feeds into the next one.
Ah, okay. Like you build the gem?
Creating the .gem file, right. Then that .gem file becomes an input, along with maybe your Docker file, to the action that builds your Docker image.
Got it. Chaining things together, like dependencies in rake.
Exactly like that. And tests are the same pattern. Code files, spec files are inputs. Run RSpec is the action. Test results are the output.
Okay.
So Bazel takes this entire web of inputs, actions, outputs, every single step, every dependency, and it represents it as a graph.
A graph.
Yeah, specifically a directed acyclic graph, a DAG. Think of your source files as the starting points, the leaves. And the actions and outputs are other nodes, connected by arrows showing what depends on what.
So Bazel literally maps out the entire dependency structure of your project.
It does exactly that. And it keeps this graph representation in memory. And that graph, That's its superpower.
Why? What does having that map let it do?
Well, because it has this complete, totally precise map, it knows exactly what depends on what.
Oh.
So imagine you change like one line in one single Ruby file. Bazel sees that file changed. It looks at its graph, and it knows precisely which actions and outputs are affected, directly or indirectly, by only that one file.
So if I change one method and I run Bazel test, what happens?
If you've set up your Bazel build files correctly, defining those dependencies,
Right.
Bazel consults the graph, sees which specific test targets list that file or a library using that file as an input.
Okay.
And it only reruns those specific tests.
Wow, that sounds incredibly fast. It knows exactly what needs redoing. Isn't there a Ruby tool that tries to do something similar, predict tests?
Yeah, the speaker actually mentioned Crystal Ball, which she worked on before. Bazel gives you that kind of really smart dependency-aware rerun behavior, but it's baked into its core because it understands that whole graph. It even tracks the tools themselves. If you update your Ruby version, Bazel knows which build or test actions used Ruby and need to be rerun with the new version.
So it's the combination of that tight environmental control, the hermeticity, and this super detailed dependency graph that makes it so efficient.
Exactly. Minimum wasted effort. It knows exactly what's stale and needs attention.
Okay, this is making sense. How does this connect back to Ruby then? How do we get our Ruby projects into this Bazel world?
Right, so that's where Rules Ruby enters the picture. It's the canonical, the official rule set within the Bazel ecosystem for adding Ruby language support.
The building blocks for Ruby in Bazel.
Pretty much. It provides the necessary pieces so Bazel can understand how to build Ruby code, how to test it, how to manage its dependencies.
And this is the part Alex Rodionov, the speaker, maintains.
That's right. It started out in the Selenium project, apparently, but now it's maintained by this Bazel Rule Authors group, the SIG. So it's kind of official.
Okay.
And you can get it easily from the central Bazel registry. Think of it like Ruby gems, but for Bazel extensions.
Right.
Bazel just pulls it down automatically.
Is it, like, experimental? Or are people actually using this in the wild?
Oh, it's definitely being used. The talk specifically mentioned Stripe is using it in production.
Okay, Stripe's a big one.
Yeah, and big open source projects too, like Protobuf and, well, Selenium itself. So it's seen some real world use.
Okay, so if I decide I want to try Rules Ruby, what does it actually give me? What are the components?
It basically provides the integration points. So number one, it handles installing and managing Ruby interpreters for you.
Like CRuby, JRuby?
Yep, CRuby, JRuby, Truffle Ruby, others. And Bazel tracks the specific version you told it to use, hermetically.
Right, a hermeticity again.
Number two, it manages your gem dependencies using Bundler. It knows how to read your gem file in gemfile.lock and set things up.
Okay.
And number three, it gives you specific functions. These are written in Bazel's configuration language, which is called Starlark. It looks a lot like Python.
The Starlark, okay. And these functions define
Your build and test targets. So you'll use things like Ruby library to tell Bazel about your source code, Ruby binary to define scripts you can run, Ruby tests for setting up RSpec, minute test, maybe Rubocop runs, and functions for building and pushing gems.
Got it. So you use these Starlark functions in special files to describe your Ruby project to Bazel.
Exactly.
How do you actually, like, start, if I have a standard Ruby project, lib, spec, gem file, gem spec?
Okay, first step is you add a file called module.bazel right at the root of your project.
Moduli.bazel.
Yep. That file basically flags the directory as a Bazel workspace root for Bazel. Then inside that module.bazel file, using Starlark, you declare, hey, I need rules Ruby. You load it, you tell it which Ruby version you want installed, like 3.3.0 or whatever.
Okay.
And you tell it to use Bundler to handle the dependencies listed in your gemfile.lock. It sets up Bazel's whole view of the Ruby environment needed for your project.
Setting the stage. What's next?
Next is defining the actual build and test targets. This happens in files named build. Usually you put a build file in each directory that has code or tests you want Bazel to manage.
So maybe a build file in the root, one in lib, one in spec, something like that.
That's a pretty common pattern, yeah. Inside a build file, you first load the specific functions you need from rules Ruby, like Ruby gem or Ruby library or Ruby test. Then you define targets using those functions. Each target has to have a name. That's how you refer to it on the command line. And crucially, it needs a deps attribute.
Dependencies, right? That builds the graph.
Exactly. The deps attribute lists all the other targets or source files that this target depends on. You use Bazel's path syntax, like it means the root of your workspace, and del_dep refers to a target name within the current build file.
Okay, so let's say I wanted to find how to build my gem. I'd put a Ruby gem target in the root build file, maybe call it my gem.
Yep.
And its deps would need to point to, like, the source code in the lib directory.
Precisely. So you'd probably have a build file inside your lib directory first.
Ah, okay.
In that build file, you define maybe a Ruby library target, call it lib sources or something, and its SRE attribute would list all your .rb files in lib.
Got it. Expose the library code as a target.
Right. Then back in your root build file, your Ruby gem target named mygem would have deps lib.libsources.
Lib.libsources, meaning the target name libsources in the build file inside the lib directory relative to the root.
You got it. Bazel uses those declarations to build its internal graph. And yeah, you generally need build files in any directory whose contents are needed as a dependency somewhere else.
Makes sense. You have to tell Bazel about all the pieces.
Yeah.
So once that's set up, how do I actually build the gem?
You just run Bazel build and then the pass to the target. So in our example, bazel build.mygem.
Meaning the root build file, target mygem.
Exactly. Bazel looks up .mygem, sees it depends on lib.libsources, makes sure that is up to date, and then runs the action to build the gem.
What about things with side effects, like pushing the built gem to Ruby gems? Builds sound pretty contained.
Good question. That's where Bazel run comes in. Bazel builds are, by default, sandboxed and hermetic. They usually don't have network access or right outside their designated output area.
Right, clean builds.
So for actions that need side effects, like pushing a gem, running database migrations, deploying something, you define a specific target for that action and execute it with Bazel run. You might define a target, say, .publishMyGem, using a function like Ruby gem push from RulesRuby. That target would declare its dependency, maybe gem.mygem.
Ah, so it depends on the build chart.
Right. When you execute Bazel run.publishMyGem, Bazel first makes sure the .mygem target is built successfully, and then it runs the push command in an environment that's allowed to have that side effect.
Okay, that distinction between build for clean outputs and run for side effects is important. What about testing?
Very similar setup. You put build files in your test directories, like spec. Inside, you define RubyTest targets.
Yeah.
A RubyTest target needs a few things. The test files themselves, srcs, the script to run the tests, like binspec, and again, crucially, the deps.
And for deps here, you only list the source code that specific test actually needs.
Ideally, yes. If you have a test for userspec.rb, it should ideally only depend on the target that exposes user.rb, not your entire lib directory, unless it truly needs everything.
Which gets us back to that super efficient rerunning you mentioned earlier. Change user.rb, only rerun tests that depend on it.
Exactly. You run the test using Bazel test. You can run a specific test target like Bazel test spec.userspec, or run everything recursively from the root with Bazel test rb.
Means everything under the current directory and below.
Yep. And here's a big win. When you run Bazel test, Bazel automatically runs all those independent Ruby test targets in parallel using your available CPU cores.
Oh, wow. So you get parallel test execution basically for free, like using parallel tests gem or something?
Kinda, yeah. It's just built into how Bazel schedules and runs independent actions. Big time saver for large test suites.
Definitely. Can you set up other tools this way? Linters, maybe.
Absolutely. You can define a target for Rubocop, for instance. It might be a RubyTest target, too, or a similar type. Its dependencies would likely be your gem file for Rubocop itself, the Rubocop executable script, and then maybe all your source code targets in lib and spec via deps.
So Rubocop runs against everything. Makes sense.
And all of this, the building, the testing, it all benefits from Bazel's caching.
Right. The caching. How does that work in practice?
Well, if you run, say, Bazel test, and then immediately run it again without changing a single file or tool, Bazel looks at the graph for every target, checks all the input, hashes the files, the tool versions, dependencies, sees they haven't changed since the last successful run, and just instantly loads the result from its local disk cache.
So it just says cached and finishes almost instantly.
Pretty much. You'll see cached next to the target names in the output. It's incredibly satisfying when it happens.
I bet.
And this caching isn't just local. This is where it gets really powerful for teams. Companies can set up a shared remote cache.
A cache everyone on the team and maybe CI can use.
Exactly. If your CI server builds and tests a specific commit, it populates the cache. Then, if you check out the same commit and run the same build or test command, Bazel can potentially pull the results directly from that shared remote cache instead of redoing the work locally.
That sounds like a massive win for CI times and developer builds, especially on bigger teams.
It absolutely is. It cuts down redundant computation significantly.
Yeah.
And you can take it even one step further.
Go on.
Remote build execution, or RBE.
Okay.
This means the actual work or the compiling, the testing, doesn't even happen on your machine or the CI agent. You run Bazel build locally, Bazel figures out what needs to be done, sends the inputs and actions to a distributed cluster of execution servers in the cloud.
Wow.
The work happens there in parallel, and the results are streamed back down to your machine.
Hmm.
Your laptop basically just orchestrates the build happening elsewhere.
That's pretty wild. So Rules Ruby potentially unlocks all of this for Ruby projects. The graph efficiency, parallel tests, local cache, even remote execution.
That's the promise, yes. It brings a lot of Bazel's core strengths to the table for Ruby.
So what's the catch? Or what's the current state? How mature is Rules Ruby? Is it all smooth sailing?
It's definitely functional. It's actively used, as we said. But, integrating a dynamic language like Ruby perfectly into a system that maybe thinks more like a compiled language world, there are always nuances.
Sure.
So it's still under active development to bring all the advanced Bazel features fully online for Ruby in the most seamless way.
What are some of the areas that still need work or are maybe limited right now?
Okay, one big one mentioned is remote build execution, specifically with C Ruby.
The RBE thing. It doesn't work with standard Ruby.
It works great with JRuby, apparently, because JRuby packages everything up nicely into portable JAR files. But C Ruby, well, getting a standalone, easily relocatable C Ruby interpreter that you can just drop onto any remote execution machine without complex setup, that's trickier.
Yeah, I can see that. C Ruby builds can depend on the environment quite a bit.
Exactly. So the speaker noted that getting that working smoothly requires some collaboration, potentially with the C Ruby core team itself.
Makes sense. What else?
Let's see. Support exists for building C extensions that need Ruby headers, and for compiling JRuby code into JRs, that seems okay. But some of the more sophisticated Bazel features are still being fully integrated for Ruby.
Like what?
Things like Bazel's native test sharding, splitting a single large test target across multiple machines for even faster execution.
Okay.
Built-in code coverage reporting. You can obviously run SimpleCov within your test target, but integrating it so Bazel understands that coverage output natively needs work.
Gotcha.
And another feature called aspects. This lets you run extra commands or checks across your dependency graph. Think like running sorbet type checks, or maybe a linter automatically as part of the build process itself.
Oh, interesting. So an aspect could enforce type checking whenever code is built?
That's the kind of thing aspects say, hey, well, yeah, that integration is still being explored for Ruby.
What about dependency management? You said bundler works, but any caveats?
It seems the core gemfile.lockflow is mostly there, but full support for things like gems hosted in private repositories or pulled directly from Git sources that might still need some enhancements to be totally robust.
Okay. And debugging?
Debugging works. You can attach debuggers, but the speaker mentioned making the integration with Ruby's standard debug gem more seamless is probably an area for improvement too.
So it sounds like the core benefits, the efficient testing based on changes, the parallel execution, the caching are definitely there now.
Yeah, those seem to be the big immediate wins.
But the team is still working on bringing some of the more advanced power user Bazel features fully into the Rules Ruby ecosystem.
That seems like a fair summary. It's a solid option, especially if you're hitting pain points with build test speed or consistency, particularly in larger projects or monorepos, and it's actively improving.
Okay. If someone listening is feeling that pain, slow CI, flaky local builds, and they're curious about Bazel and Rules Ruby, where should they go to learn more?
Well, the talk points directly to the Rules Ruby GitHub repository. That's the main hub for code, documentation, issues.
Standard place for an open source project.
Yep. There's also apparently a dedicated #Ruby channel on the Bazel Build Slack workspace. Good place for questions, getting community help.
Okay, good resources.
And the speaker, Rodionov, also mentioned being reachable via email for specific queries.
Great. So lots of places to dig deeper. Okay, so we've really unpacked this talk, haven't we? We looked at Bazel, this build tool born from Google's scale problems.
Right, focusing on polyglot support, hermeticity, reproducibility.
And how it uses this concept of a dependency graph to be super efficient.
And then how Rules Ruby tries to bring all that power, the graph, the caching, the parallel execution to the Ruby world.
Offering some potentially big wins for build and test times, consistency, especially as projects grow, while also seeing where it's still, evolving.
Exactly. It's a different way of thinking about the build process for Ruby.
What really stands out to you after diving into this, for me, it's still that idea of targeted testing. Changing one file, running maybe just one test. That feedback loop shortening is just huge.
Yeah, that's compelling. For me, it's seeing these really hardcore infrastructure ideas, things designed for massive distributed systems being carefully adapted and applied to make life better for development in a dynamic language like Ruby. It's an interesting intersection.
It really is. So maybe a final thought for you listening. If your current build and test cycle could be modeled and optimized like that, like a super efficient dependency-aware graph, what would you actually do with the extra time and reduced frustration?
Yeah. What does shaving 10, 20, maybe even 50% off your build and test times unlock for you and your team? Something to think about.
Definitely something to think about. Thanks for digging into this with us today.
My pleasure. Always interesting stuff.